We'll just breeze through this first. So hyperbola, we're looking at a hyperbola. It's a function with its equation in the form xy equals some constant or y equals a over x. You did look at these in year 10. For example, sketching y equals 1 on x. There will be, we look at it and we know straight away that x can't equal 0. So we already know that in the domain that it will be all real x is not equal to 0 because you're not allowed to have x equals 0 because it's on the denominator. So y equals 1 on x is a discontinuous curve since the function is undefined at x is 0. And if we substitute in values of x, you've got to remember for the hyperbola, when you first learn how to sketch it, you need to do fractional values because you might do when x is 1, y is 1. When x is 2, y is a half. When x is 3, y is a third. So x is 1, y is 1, x is 2, y is a half, x is 3, y is a third. But we need to see what happens to the function up here. So we take fractional values. When x is a half, 1 divided by half is 1 times 2, which is 2. When x is a quarter, 1 divided by a quarter is 1 times 4, which is 4. So notice that this y-axis here is an asymptote. The curve approaches the y-axis, but will never touch it. The x-axis down here is also an asymptote. Notice the quadrants. This is quadrant 1, 2, 3, 4. Now, when we substitute in negative values of x, when x is negative 1, y is negative 1. When x is negative 2, you get negative a half. X is negative 3, negative a third. But then we know, yes, that bit of the graph there, but we need to see what happens for smaller values, negative values of x. So you can put in fractional values. When x is negative a half, y is negative 2. When x is negative a quarter, y is negative 4, hence the curve goes down here as well. Negative y-axis is an asymptote. Negative x-axis is also an asymptote. So I'm calling this, see this bit where I'm over here, this is the positive x-axis, because the positive values of x are there. This is the negative x-axis that I'm highlighting here, the positive y-axis and the negative y-axis. They're all asymptotes, okay? However, I would say over here, as x approaches infinity, positive infinity, y approaches 0 from above or below? From the positive y values or from the negative y values? All right, I'm going to show you that now. So you would not be substituting in values, all right? You need to know the general shape. So just looking at the curve y equals 1 on x, it looks like this. When you're sketching a graph, you do need to put in, you can't just draw the sketch with no points indicated. So I know, for example, that that's the point 1, 1, and that this is the point negative 1, negative 1. You do not need to put markings on the y-axis or the x-axis to show me that. Don't do that. It takes too long. It's too hard to draw it to scale in the time frame. Whenever you're drawing a graph, you should have 2 points represented on the graph, because with the 2 points you'd be able to work out the equation of the graph. So I can say here, just looking at notation, as x approaches positive infinity, so as x approaches big positive y values, y approaches 0. Wouldn't you say, look, when x is 10, isn't y 1/10? But it approaches it from above. Like it's not negative 1/10. You'll understand when I come over here, all right? I could say as x approaches 0 from above, so from the positive end. Does that make sense? As x approaches 0 from the positive end, doesn't y approach what? Positive infinity. Do you get it? So as x approaches 0, start coming from the positive numbers. Like if x is 1/10, 1 divided by 1/10 is 10. Y approaches positive infinity. Y gets really big as x approaches 0 from the positive numbers. Now, as x approaches negative infinity, y does approach 0, but from above or below 0? Yeah, y approaches 0 from below. So what I'm going to do here, this little plus up here means from above. And this is from below. From the negative values. All right? And as x approaches 0 from below, or from the left-hand side, what does y approach? As x approaches 0 from the left, doesn't y approach what? What sorts of values? Negative values. Y approaches negative infinity. Okay? I know, for example, over here that I'm approaching 0, but I'm approaching it from above the line, above the x-axis. So, for example, this would have a positive y value. And down here I would have, as I'm approaching big values of negative x, when x has big negative values, my y values are approaching 0, but from the negative side. Okay? Now, this is clearly what sort of function as well? This function is also an odd function. This is also an odd function. Why? Because what sort of, does it have line symmetry, y-axis line symmetry, or does it have point symmetry? As it has point symmetry, and I could do function of, let's just prove it as well. If y equals 1 on x, right, what's the function of x is 1 on x. The function of negative x is 1 over negative x, which is negative 1 on x. And doesn't that happen to equal? Now, what you can do, you can show now that that is the negative function of x, or you can do negative function of x separately on its own. It's up to you. So I've said that that's an odd function because it's got point symmetry. That's just by looking at the graph, but I can also show it algebraically. So y equals function of x, in other words, function of x is 1 on x, function of negative x is that. I can now just go negative function of x is negative 1 on x, which is negative 1 on x. Therefore, can you see that the function of negative x equals negative function of x? I could have just gone here, which equals negative function of x. Do you get it? I could have said, yeah, that is the negative function of x. I could have just done that here, equals negative function of x. Or I can do negative function of x separately and then say, well, those two are the same. So therefore, function of negative x equals negative function of x. Therefore, it's an odd function. But we knew it was odd because it has point symmetry. But once you start shifting the graph, it's not going to be odd anymore, and I'll show you. Okay? This topic, you'll have to sketch things. Is it an odd or even function? What is the domain and range? Pretty much. Okay, what's the domain of this function, please? What's the domain? All real x, comma, x can't equal 0. And the range is all real y, comma, y cannot equal 0. Yes, all the positive y values, all the negative y values, but y can't equal 0. So, is the function odd? Is it even? And we can ask you, what's the domain, what's the range? All right? Now we're going to look at transformations of the hyperbola. Now, because you know transformations of the parabola, this should be very easy. Sideway movement, up and down movement. That's all you've got to know. So, equals 1 on x, which is a hyperbola, just your general hyperbola in red. Y equals 1 over x plus 2 is shifted. It's a sideways shift because I can put this in brackets, but I don't need to because it's contained on the denominator. It's shifted. What makes the x plus 2 equal to 0? You're not allowed to have x plus 2 equals 0. X is negative 2 gives you that value. What would be the domain of this function? All real x. X is not equal to negative 2. What about the range? All real y except for y can't equal 0. And here is another shift, but the denominator can't equal 0. X minus 3 can't equal 0, and so x cannot equal 3. All real x for your domain, x can't equal 3. Range, all real y, y can't equal 0. So I'll get rid of those. And let's look at a y equals 1 over x plus 2. Where's this graph going if I put plus? If I do plus 2 on the end, it goes up. It's the y equals 1 on x curve, and once I've calculated all those values, I add 2 onto them. So the whole graph gets shifted up. It's the same with the parabola. When you add on a constant term at the end, the whole graph gets shifted up. So, what is the domain of this graph? all real x can't equal 0, but your range, all real y can't equal 2. See, you're not allowed to have the y value of 2, because that's the new asymptote. Yes. Right, next, y equals 1 over x minus 3. Right, that's the purple graph, this one. This is the y equals 1 on x curve. The whole graph has been moved down 3 units. So domain, all real x except 0, range, all real y can't equal 3. Now, we're going to sketch these in a minute. We've also got the negative hyperbola, y equals negative 1 over x, is in quadrants. So y equals 1 on x is in quadrants 1 and 3. Y equals negative 1 on x is quadrants 2 and 4. Okay, still an odd function, point symmetry. However, those other ones, the curves that have been transformed aren't odd or even, and they're not odd anymore. We will look at that soon. And then I can move, I'm going to get rid of the red function, and then I can do the transformations on the negative hyperbola as well. So negative 1 on x. What about if I go plus 3? Where's this one going to go? Up, down, left or right? Yeah. And if I go y equals negative 1 on x. Yes, I did. Y equals negative 1 over x plus 2. That goes to the left 2 units. So when your transformation is, so it's still the negative 1 in quadrants 2 and 4, even though I'm overlapping here, but the whole graph got shifted 2 units to the right, to the left. This one up here got shifted 3 units up, the red one. Okay? All good? So, transformations are the same, but you need to see if it's a negative hyperbola or a positive hyperbola. All right, now, getting rid of those. Right, one other thing we haven't looked at is steepness. So y equals 1 on x. Y equals 3 over x. Same shape, but it's sort of wider out. It's a bit wider away from the asymptotes, but it will eventually. Okay, but you know it's because when x is 3, when x is 1, y is 3. X is 1, y is 3. If you look at that point. When x is 3, y is 1. All right? You can just tell by substitution that that's how it would be. And then I could still shift that up or down, but it's still going to be, the shape's going to be the same, but just a bit wider out. Okay? So if I did y equals negative 1 on x, remember that's the orange one there in quadrants 2 and 4. Y equals negative 4 on x would just be a wider version of that, the purple one. Okay? All right. Or find the domain and range. It's in quadrants 1 and 3. It's a little bit wider out. That's okay. You could plot a few points, like when x is, we can't have x is 3, right? Where's your asymptote? There's a sideways shift to x is 3, all right? Okay, let's do that. So we're going to sketch this function, find the domain and range, okay? And we're going to practice odd and even as well. So, should be able to sketch that. It's in, you look at it and you say, yep, quadrants 1 and 3. X minus 3 can't equal 0, so x cannot equal 3. That's where your asymptote is, at positive 3. And you know it's the quadrant 1 and 3 type like that. Now, it's not enough just to do that sketch. Like if you're asked to sketch it, I need some points. It would be really good to do the y-intercept, wouldn't it? Y-intercept would be a good value to do here. So what's y-intercept? Isn't that when x is 0? What do you get? Y is 3 over 0 minus 3, which is negative 1. So there's whenever you're sketching, I want 2 points shown on the graph. What would be another nice value? This asymptote's at 3. What do I do when x is? You can do 4, or you can do x is 6 would be maybe nice, or whatever. Oh, no, x is 4 is good. What about when x is 4, what would you get? 3 over 1. Do you see? And I'm just doing another point. When x is 4, y is 3 over 4 minus 3. 3 over 1 is 3. So it's a good thing to show a couple of points on the graph, because if you're asked to sketch it, yes, you can put the asymptote in, unless you're putting something else like this y-intercept or this 4, 3. You wouldn't know if this is the curve 1 over x minus 3 or 2 over x minus 3. Do you get it? All I know by the asymptote is that it's something over x minus 3. Unless I substitute and find the y-intercept or this other value here at 4, 3, I'd never be able to know that that is actually that function there, because it could have any other number, constant on the numerator. But by doing the substitutions, I know that it's the function y equals 3 over x minus 3. So let's look at the domain. What's the domain? All real x, comma, x is not equal to 3. And the range is all real y, what? Y is not equal to 0. Okay? Let's see, is the function odd, even, or neither? Is the function odd, even, or neither? Let's have a look. I can tell by the sketch that it's neither. But let's do it algebraically. Can you see that it's not symmetrical about the x-axis when you look at the function? And it doesn't have point symmetry because it's been shifted. So let's have a look. Function of x is 3 over x minus 3. Function of negative x is 3 over negative x minus 3, which is 3 over negative x minus 3. Now, you know how I've got those two negatives on the denominator? I'm going to, watch what I'm going to do. I'm going to go 3 over negative x plus 3. You okay with that? Isn't that the same as negative 3 over x plus 3? And I'm now going to do the negative function of x. I'm just going to throw a negative in front of my function of x. Now my function of x is 3 over x minus 3. So negative function of x, isn't it just negative 3 over x minus 3? I'm just putting a negative there either on the numerator or the denominator. I'm not going to put it on the denominator, otherwise I'd need brackets. Are they the same? Function of negative x, and so therefore function of x does not equal function of negative x, and the function of negative x does not equal the negative function of x, so it's not odd, not even, and it's not an odd function. So it's not even nor odd, but you know what? We knew that just by looking at it. It doesn't have point symmetry anymore. The first one did, y equals 1 on x, but once you start shifting sideways and up or down, your hyperbola doesn't have point symmetry anymore, and it's not an odd function anymore. And it's because of the constant. Okay? We want to sketch it, find the domain and range. Okay? So, what can we do? Just be careful. What could you do with the denominator? Take out the 2. So, where is the shift? 4 units or 2 units? To the left or right? Well, what we could do, even if you didn't take out the 2, you could say, I know that 2x plus 4 can't equal 0, right? So I know that x cannot equal negative 2. Now, whether you factorized out the 2 first or didn't, that's going to happen. X can't equal negative 2. Do you see? So, therefore, this is a hyperbola shifted to where? To negative 2. Like two units to the left. Is it a quadrant 1 and 3 or a 2 and 4? What quadrants 2 and 4? It's the negative hyperbola, so it's going to look like this. But you are going to have to give me 2 values, please. And what value would be really good to give? The y-intercept, and then I want another value over here somewhere. So when x is 0, y is negative 1 over 0 plus 4, which is, isn't it negative a quarter? So that's your y-intercept's negative a quarter. I know it's not drawn to scale, it doesn't matter. As long as I don't have little markings everywhere, it doesn't matter if it's not to scale. And let's just do another nice value of x over here. You could do negative 3 might work, but negative 4 might work. Doesn't matter. I'll do x is negative 3. When x is negative 3, y is negative 1 over 2 times negative 3 is negative 6 plus 4. So it's negative 1 over negative 2, which is positive a half. So here is another value. I know it's not to scale. That's negative 3 a half. Okay? So let's just look at, this is not going to be an odd or even function. All right? So you can tell by the sketch. It doesn't have line symmetry about the y-axis, and it doesn't have point symmetry about the origin. What's the domain? All real x, comma, x is not equal to, and the range is all real y, y is not equal to 0. Now I'm going to do one more. One more. Sketch, give me the domain and range. The last one. So this is a combination of transformations. So we need to say, right, this is y equals 2 over x shifted where? It's got two shifts. Shifted to the left 3 units and down 4 units. So shifted 3 units left, 4 down 4 units. So you don't have to draw it, you know, perfectly. Just a quick sketch. And it's in quadrants 1 and 3. So let's shift it 3 units to the left. That would put the asymptote there at negative 3. And 4 units down would give me an asymptote at negative 4. Because normally my asymptotes are at x-axis and y-axis. And it's going to be in quadrants 1 and 3. Now I'm going to draw it in a different colour because we can't tell what the axis is. So we've got quadrants 1 and 3. 1, 3. No. Sorry. Anyone got tapey stuff? Right. So get rid of that. You can see what the, look, we'll need to, let's just substitute x is 0 for our y-intercept. And what do we get? Y is 2/3 minus 4. Someone's got to help me with that. Negative 3 1/3. I know it's not drawn to scale, okay? And you could just do some other value. When y, I'm going to put negative 6 because that looks like it'll work nicely. No. I want to put 2. What would... y is negative 5. I've got 2 over negative 2. Isn't that 2 over negative 1 minus 4? Sorry, when x is negative 5, sorry, y is negative 5 as well. So just showing another point on the graph. I know that wasn't drawn very well. Negative 5, negative 5. And domain and range, girls. Domain, range. All real x. X is not equal to negative 3, and range all real y. Y is not equal to negative 4. Okay? Sorry about this. Sketch should have been lower down, but don't worry.